In solving worded problems that ask for the minimum or maximum of something, we often use dy dx equal to 0, or something like that. Well, it is a very powerful method. If we use it blindly, there is a pitfall. It is very important to visualize the situation. This Comet question is a very good example of that. In this Comet question, y is equal to half x squared take away 4 was given. But if we differentiate it, and then we get wrong answer to answer the question. Let's take a look at this situation. Now at this stage, if I was doing this question, I would not know exactly what to do. But I know for sure dy dx is equal to 0 is wrong, or not helpful information, because the turning point is there, and the situation is that we have Mars at the origin or the center. And then we have the comet coming along in this pathway. If you use dy dx, then we are just finding this turning point, which is not necessarily the minimum distance between the comet and Mars. For example, it could be somewhere like here. So for this point, x and y, let's call this point x and y, we want to minimize this distance between comet and Mars, that is c. To do this, we need to come up with a mathematical expression for c. How do we do that? Well, remember Pythagoras' theorem, where it states this side squared plus that side squared is equal to hypotenuse length, which is c squared. So we call this length x and we call this length y. Then we come up with this formula. Now, before we go into the formula, let's make it clear what c stands for. We write, let c be the distance between Mars and the comet. Then that would be the expression. But we have two unknowns. That's not good. We cannot really differentiate it and get a useful information. So we need to substitute this y is equal to half x squared take away 4 in place of y. When we do that, we get this expression. Next step, we are going to simplify that, which is this. We expanded this out. Sorry, it's not simplify. Then what we are going to do is we need expression for c, so we will square root this expression, and we get c is equal to square root of quarter of x to the power 4 take away 3x squared plus 16. Now I make note of c has to be greater than 0 because c is distance, so we omit the case when this square root has negative sign at the front. Distance being less than 0 doesn't make sense. Then next thing we want to do is we want to use calculus, so we want to minimize c. We want to have, in other words, make dc dx equal to 0. So that's the expression for dc dx. So we want to substitute dc dx is equal to 0, making note of it here that minimum or maximum c occurs when dc dx is equal to 0. So we have that expression here. When you solve this, you notice that you can multiply this expression and 0 by square root of whatever this denominator is, which gets rid of them, and then x to the power of cube take away 6x is equal to 0. We need to solve that. And by factorization or other methods, we get x equal to 0 or x is equal to 6. That's when dc dx equal to 0. However, at this stage, we cannot tell which point's minimum and which point is maximum. So there are a number of ways of doing this. you can differentiate this expression again and perform the second derivative test, which can be very painful. Or you can also do a sign test where you substitute the value of 0.1, negative 0.1, something that's close to 0, but you use both sides and substitute each of these x values into dc dx. And you will see whether this point constitute as minimum or maximum. And do the same for 6. However, I will do a third way. That is, I will substitute both of these numbers into c and see which one turns out to be minimum, because minimum has to be one of these. And as we see here, that the distance between Mars and Comet will just diverge into infinity as the parabola goes to infinity. When x equal to 0, when you substitute that to c, you will find c is equal to 4. When x is equal to 6, then you will find c is equal to square root of 7. So square root of 7 is smaller than 4. Please confirm it with your calculator. Therefore, the answer is that the minimum distance between Mars and the comet is square root of 7 million kilometers. Now, it is also important to note here that there is a possible case where this denominator is equal to 0. But if that is the case, then this derivative test will fail. But notice that this expression is c. So this expression doesn't make sense only when c is equal to c is equal to 0. Is it the case for x equal to 0 or x equal to 6? No, c was non-zero number. So we can rightfully say that here, and square root of this expression does not equal to 0, which is really supplementing that this expression dc dx exists for these points, which is very important.